This is one of the most beautiful exploits that I've seen in a very long time. We're talking about a vulnerability in AppArmor, which is a Linux kernel security module that allows you to do access controls on programs and files that you're actually able to use to escalate to root. So the security tool is the vulnerability. Really weird. So to go into this, gotta kind of talk about what AppArmor is. AppArmor is this really powerful tool that runs on the kernel that allows you to write profiles that allow and deny different programs, users, etc., to do certain actions on the computer. So for example, I have a program here called readit. We'll show you what readit does here in a second. Obviously, by the name, it reads a file. I wrote this profile that basically says, hey, the program readit can read itself so that it can run. It can allocate a PTY and do all that normal stuff, but it's not allowed to read files in the temp directory. It's kind of just a very simple example, okay? So we'll show you real quick that if I use the readit program, I can read right now the temp test file. It's hee. But if I invoke the readit profile, which mind you does require root access, we'll get into why this doesn't matter here in a minute. By invoking this profile, now what I'm able to do is not able to read temp files. This is a really powerful way of doing access control, kind of a zero trust architecture. So certain programs, certain users, when things go wrong on your computer, can't access the entire system, right? But what happens if there's a vulnerability in your access control solution? Well, this is exactly what's going on. The vulnerability was found by the Qualys team. So obviously, guys, go read their full report. There's a lot of detail in here that I'm going to kind of skim over. Their work, as usual, is incredible. And they obviously just write it in a text file, which I find hilarious and beautiful all at the same time. So the vulnerability is really interesting, and it stems from this thing that's called the confused deputy problem, where, for example, you have programs like Sudo, and Sudo is this program that's really weird because it is a program that runs as root, right? If you want to change your user to another user, you, by the nature of how that process works, you have to run the program as root. But the problem is, if there are certain features or certain other parts of the computer that do access controls based on what privilege your process is, this can be problematic. You're confusing the program as to who you are and therefore controlling it to make it do evil stuff. Hence, confused deputy. So you saw in the demo before, I had to load a AppArmor profile, right? Under the hood, what this eventually turns into is there is a path here called sys kernel security AppArmor with these 3 meta files, right? Load, replace, and remove. They're not actual files. They're just like stub files that are controlled by the kernel. And when you write to this file, it invokes a kernel security module in the kernel that checks for the permissions of the process. You'll note that the process is the important caveat here because these files are actually readable and writable by every user on the computer. It is owned by root and is owned by the root group. It is owned by the root group. But again, I'll show you that I can write to it, but the actual act of invoking a profile will be denied by my current user. So if I go back into the computer, I type ID, I'm Ubuntu, right? And I try to write some kind of data, an AppArmor profile to either allow or deny a program to do something. If I do this, even though the file itself is writable by me, the actual act of creating a profile is denied, right? It says permission denied, which makes sense. I'm not root. I should not be able to do that. Unsurprisingly, however, opening these files in write-only mode succeeds. Actually writing to them as an unprivileged user fails with e-access permission denied, which makes sense. And we can even check the D message, the kernel security log of the computer, and it says, hey man, there's an audit. User whoever I am tried to write to a file that was a profile and they're not a policy admin. They can't do that. You probably should investigate. What if a privileged user who should be doing something else is used to write to this file in a privileged context? So this is where the Sudo binary gets really important, okay? If we look at the permissions of Sudo, again, Sudo is a program used to switch the current user, and again, that is a privileged program that requires it to be a set UID binary, meaning when you run Sudo, the program immediately escalates to root. Now that's okay because the logic inside of Sudo does not allow you to do evil stuff. Sudo itself checks for the password and all that other stuff so that you can't just sue to whoever you want to be. But what if we use the Sudo binary, which is now a privileged process, to write to a file that depends on privileged users to do it? And that's exactly what Qualys discovered. Today's video is sponsored by yours truly, me. Guys, in the era of AI everything, it is becoming more and more important to understand how computers work at a fundamental level. Even though code can be emitted by an AI large language model extremely fast, the people that want to stand out from the crowd know what's actually going on by knowing how memory works, by knowing how pointers work. And the best way to learn how those things work is by understanding a language at a low level like C or assembly. In my new revamped C programming course, you guys can learn what C is, how it works, how pointers work, and then at the end of the course, write your own key value store and get it automatically graded. And if you pass the course, you get a certificate of completion to show your future employer. Guys, you can't write good code or safe code if you don't know the fundamentals, and where do you learn the fundamentals? At Low Level Academy. they could use the Su binary to put the standard error data into the remove file. And because Su is a program that runs as root, the kernel security module will see that the calling process is owned by root and allow it to do its evil bidding. So by running Su, I'm actually running a program as root, and I can sue to a user that doesn't exist. We'll say whatever, just like Qualys does in their example, right? But then if I pipe the standard out or the standard error data of this to that file, you'll notice that it doesn't say permission denied. Well, because I'm pumping the standard error out. Well, actually what's going on here, if we go back to the security logs, it actually is allowing us to do this. We can see right here, it says profile does not exist. It tried to remove the profile of whatever the standard error data was, which means we've completely bypassed the requirement for root users to use AppArmor. Like we, as a user that uses the Su binary, a setuid binary, can control AppArmor. So then from this point, all we have to do now is figure out a way to use the Su binary to emit arbitrary data by running a command as somebody. And then through doing this, we're able to control what data we send to these profiles, and therefore we can arbitrarily load and remove AppArmor profiles. So let's try this command out real quick and let's not pipe it out. Let's just see what it does. So if we do this, we'll type in the password for the current user. This is not the root password. I'm literally just suing to myself. Do the password here, ABC123. What I'm able to do is use the STTY functionality within Su and just tell it to run arbitrary commands through echo, right? By doing this, I'm able to write whatever data I want to standard out, and in the context of how this is being ran, it is being ran as a root process. It's being run, right grammar, shut up, this is how I talk. So ultimately, by taking this data, using the process that's currently privileged and writing it out to this file, it's a meta file, we're able to control what loaded profiles exist or remove profiles from AppArmor as a user that is not root. So again, literally I can just remove, and again, I'm typing my password, not the root password. I can remove the rsyslogd profile that only allows root to write to the syslog daemon, which is insane. So that's all well and good, right? We have a file, we used a privileged program to write to a privileged file, nothing too crazy going on there, right? Those kinds of bugs have actually been around since like 2012, not this bug in particular, but like that kind of bug has existed for a long time. How do we use this, the arbitrary addition or subtraction, to get to be root, to run code as root? This part of the write-up is where I actually gasped when I saw this. They use AppArmor and Sudo, like the normal do something as root program, and Postfix, the mailer daemon that sends mail, to become root. If you don't know, if you try to Su as root, and you have Postfix installed, right? And you fail to Su as root, like you can't do it or something, you're not in the sudoers file, for example, it says this issue will be reported, right? It literally says that. Like, I'll show you right now. So I made a new user, hehe. I use that word a lot. I'm not sure. I just find it very funny. It's like very short and sweet. So we have the user hehe is not a sudoer. So if I use a sudo command and I type in my local hehe password, which is hehe, by the way, it'll alert me, hey man, hehe is not in the sudoers file. This incident will be reported. What actually happens under the hood is the program goes as the hehe user and sends an email to the admin to say like, hey, this guy keeps trying to sudo. You probably shouldn't do that. And under the hood, it uses the Postfix program, which I just installed on my computer. Our burning question therefore became, if we as an unprivileged local attacker load a new AppArmor profile that denies the setuid capability, this is where it gets insane. We're not adding a malicious privilege, we're denying the ability to set UID. We'll go into this here in a second. If we deny the setuid capability to sudo, thereby potentially preventing sudo from dropping its root privileges before it executes postfix send mail, if we execute sudo with a mail config environment that points to our own postfix config, can we execute postfix as root? And the way that this works is fucking bonkers. Now, before I go into reading through the exploit, I want to highlight, I spent around 45 minutes trying to get this set up. I'm on an older version of Ubuntu where I think there's a difference between the way that postfix runs on sudo and this version. Listen, I tried to get a demo set up for you guys. I couldn't make it happen, okay? I'm kind of freaking out a little bit, but I'm going to walk through Qualys' very, very nice example, and that's where we're going to end it, okay? So basically, you make a directory for temp postfix, you set up the command directory in this postfix config file to contain a post drop script that runs after mail has been sent. And what happens is you set up an AppArmor profile, again, doing this not as root, that denies the sudo binary from doing setuid capabilities, right? So when you install this and then you try to run sudo, what happens is you can set the mail config environment variable for postfix, okay? You set it to temp/postfix, and then as sudo is trying to run and it tries to send the email, the sudo binary is elevated to root because it is sudo. That's how sudo works. But then after that, it's trying to set the permissions to the sudoers file to process if you are or not a sudoer, and then it's trying to set the privileges back down to your users, and because you've denied the capability of doing setuid, it leaves the binary as root. Oh, and also, because it didn't do a setuid or setreuid system call, it maintains the environment. So you effectively call postfix as root with a user-controlled environment variable that tells postfix as root to run this script. And in the example here, they show that the ID of the user is Jane, the normal user for the exploit, but also they have the effective user ID of root. That is like fantissimo. That is absolutely crazy, guys. Like the confused deputy problem is so interesting because it's one of those bugs or one of those like bug archetypes that it's not traditional, oh, bad memory. Oh, it's not traditional like cryptographic misimplementation. It's like we have these two systems that make assumptions about who is using them. And if you combine those assumptions incorrectly, you violate the entire security promise of the application. So again, AppArmor is a good thing. I'm not going to sit here and be like, oh, don't use AppArmor. AppArmor is bad. No, AppArmor is awesome. The answer to this problem is go and update your stuff. Go update to the latest version of AppArmor. Go update your sudo binary to the latest one. I do want to highlight that, like, you know, sudo being a setuid binary is not necessarily a bad thing, but the nature of setuid binaries has like been a huge attack surface for a very long time. I think Qualys actually drops a significant number of the su and sudo bugs that come out. So keep an eye on their stuff. They do a lot of great work and really, really cool research. And to answer your begging question, would Rust have fixed this? No. This is a bug in the logic of the check in a Linux kernel security module that Rust would not have fixed for two reasons. One, Rust doesn't stop logic issues, and two, writing Rust in the kernel is like really freaking hard to do correctly. Anyway, guys, that's it for now. Thanks for watching. If you enjoyed this video, check out this other video about an IP camera that I hacked. It's kind of bonkers, actually. We'll see you over there. Take care. Bye.